Hello friends, today we're going to learn how we use solver to solve a given linear programming problem. For this we take a very small example which consists of two variables and three constants. Now before we solve this using solver, let us first learn how to install or how to load solver in the Excel add-ins. For this we go to File, then go to Options, select the add-ins from here. Go to Manage, make sure that you have the Excel add-ins visible over here. Click Go. From the list of add-ins available over here, you select this box of Solver add-in. Click OK. So when you do this, when you click on the data, you will see the Solver icon visible over here. Now this Solver is ready for use. So now let us start preparing for using this solver, right? So I'll be creating certain spaces over here. The first one will be the space for the coefficients, the space for the coefficient of the variable in the objective function. So what I'll write is z coefficient for decision variable. Decisions variable. The decisions variables are x1 and x2, right? Then we also create the same for the constants. Constant coefficients for the decisions variable. Constants coefficients for decisions variable. So the decisions variables are x1 and x2 again. We also create an additional column called the left hand side where we will be inserting the formulas. This will be the relation of the constants. Then the right hand side. The right hand side of the constants will be entered in this column. And finally the slash oblique surplus variables. Now let's start entering the values, right? Let's start entering the values. For the first constant, this is the first constant, the second constant, and the third constants. For the first constants, the values are 1.075, and the relation is less than equals to. The right hand side value will be 4. Then the next one is 2, 5. The relation I think is greater than or equal to, and the right hand side value is 20. The coefficients for the third constants are 1 and 1. The relation is equality, and the right hand side value is 5. Now then what we do is we now create this space for the solution. Solution space. Over here we will have the values of the variables after you solve the problem, and we also create an additional space for the value of the objective function. So this is where the values will come. The solution values will come after you solve the problem using solver. Now here we will be inserting a formula using the sum product. This will be the sum product of the values of the variable that you will have after solving into the corresponding coefficients of the variables in the objective function. So I forgot to enter the values. Let me enter the values of the coefficient of x1 in z is 10, coefficient of x2 in z is 15. Insert a blank row. Sorry. Let's check the formula again. Yeah, the formula is okay. Now over here the left hand side formulas will be the sum product of these coefficients and the values of the variable that you'll have after solving the problem, right? So what we'll do is the same will be done over here. Sum product between these coefficients and the variables over here, the variable values. Since this is going to be used for all the constants, you can freeze this one. So I'll lock these cells, the solution cells, so that I don't have to type the formulas again and again. You just copy the form, you can just drag the values and the formulas will be applied to all the remaining rows. You can see over here, this is the sum product of the coefficients and the values of the distance variable that you'll have over here. Now the first constant is less than or equal to, so you'll have the value of slack variable. In this case, slack is the right hand minus the left hand, and then the second one is greater than or equal to is a surplus. Surplus should be the right hand minus the left hand, and the last one it's equality, so it should be right hand minus left hand. This will have a zero value, right? Now let's start. Now you're in a position. Now you're in a position to go to solver and solve the problem. Let's go to solver and find out a solution to the given linear programming problem. Data, then solver. So this is the space for the cell where the objective function formula was created. This is the one. Your objective is maximization. This is the maximization. So you select the maximization, and this space is meant for the cells where the solution should come. These are the cells where the solution should come. Then now let's add the constraints. The first constraint, the left hand side value, the relation is less than or equals to, then the right hand side value, right? Then second constraint, left hand side value, the relation is greater than or equal to, and the right hand side value 8. The next constraint, left hand side, the relation is equality, and the right hand side. Click OK and come out. Select the non-negativity conditions of the variables. Over here, from these options you select the simplex, then click OK. See, the solver found a solution. All the constraints and optimality conditions are satisfied, and hence you have solved the problem. Your optimum solutions to the given problem has reached. The optimum solution to the given problem is x1 equals to 0 and x2 equal to 5, and the corresponding value of z is 75. Hence, this is how you solve a given linear programming problem using Excel solver.